Alright guys, in this video we're going to investigate inverse functions and also inverse trig functions. So first of all, what are inverse functions? Symbol for a function is f of x, as you guys know this already. And the symbol for inverse function is f to the power of -1 and then x. So for example, if f of x is equal to x, let's say 2x. What is the inverse function of it? It's equal to x on 2. I'll show you. So if x is equal to 0, 1, 2, 3, 4, 5, what are the values of the y? Y is equal to 2 times x, so it was 2 times 0. So the 0, and this is 2, this is 4, 2 times 3 is 6, and 8, and this is 10. Now, what about this one? What are the so if I set the x values to be the y values that are here, so 0, 2, 4, 6, 8, and 10, what are the y values? Y values are 0 divided by 2 is 0, 2 divided by 2 is 1, 4 divided by 2 is 2, 6 divided by 2 is 3, 4, and 5. So you can see that the x values here are the same as y values over here, and the y values over here are the same as the x values over here. So that's what inverse function is really all about. Okay, so that's an inverse function of this function right here. So 2x is also an inverse function of x on 2. Now, take for example f of x is equal to x squared. So what's the inverse function of this one? So think about it. When x values are 0, 1, 2, 3, 4, 5. So what's 0? What are the y values? 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16, and 5 squared is 25. Well, what is the inverse function of this one? It's very easy. All you have to do is so this is how you do it. For this one over here, you have y is equal to 2x, and if you simply just swap x and y, then you get x is equal to 2y. And all you have to do is just rearrange this so you get y as the subject. So you just divide by 2, then you get x on 2 is equal to y, and that is your inverse function, which is x on 2 right here. So this one over here is y equals to x squared. So if you just swap x and y, then it becomes x is equal to y squared. And if you just take square root on both sides, then you get square root x is equal to y. Of course, you get a plus and minus, but we're just going to take a positive value because it will no longer be a function if you take both positive and negative. So there you go. So this inverse function is f of inverse f to the power of -1 bracket x is equal to square root of x. So therefore, if y values, x values are the y values here, then the y values will be the x values over here. So when x values are 0, 1, 4, 9, 16, 25, then you get, so what's square root of 0? That's 0. Square root of 1 is 1. Square root of 4 is 2. And this is 3. This is 4. This is 5. So that's an inverse function of the y equals x squared. Now, okay. Now consider this function. F of x is equal to 2 to the power of x. Then when x is equal to, I'm going to consider negative numbers here as well. -3, -2, -1, 0, 1, 2, 3. So 2 to the power of -3 is nothing more than just 1 on 8. 2 to the power of -2 is 1 on 4. 2 to the power of -1 is 1 on 2. 2 to the power of 0, anything to the power of 0 is 1. And 2 to the power of 1 is 2, and this is 4. And 2 to the power of 3 is 8. So that's an exponential function. So what is the inverse function of this one? Guess what? The inverse function of the 2 to the power of x is log base of 2x. So therefore, when x is 1 on 8, you get y value as -3. See, log is all about the power. So when you plug in the result into the x with the base of 2, you get the power, all right? So you see y is the power right here. If you plug in 1 on 4 quarter into the x, then you get -2. -2 is the power. And the 1 on 2, you get -1. And when you plug in 1, then you get 0. And when you plug in 2, then you get 1. When you plug in 4, then you get 2. When you plug in 8, then you get 3. So log 2 8 is 3. Log 2 4 is 2, so on and so forth. Okay? Well, so if f of x is equal to now sine of x, what is the inverse function of the sine of x? The answer is the f inverse is equal to the sine -1x. All right, so for inverse sine function, we just adopt this symbol -1, and we put it there. And as I explained this in the previous video, sine to power of -1x, this is the inverse function of sine, and this is not the same thing as sine of x all to power of -1, which is actually the same thing as cosec function. All right. So when x values are, for example, 0, pi over 6, which is 30 degrees, pi on 4, pi on 3, pi on 2, the y values are 0, half, that's square root 2 on 2, that's square root 3 on 2, and that's 1. In the same way, when the x values here are 0, half, square root 2 on 2, square root 3 on 2, and 1, the values that you get for y are 0, pi on 6, pi on 4, pi on 3, and pi on 2. Okay, so when you plot y equals to 2x, then you get a straight line with gradient of 2. So that's going to be like this, okay? So this is y equals to 2x with gradient of 2, and it goes through, for example, when x is equal to 4, 4 times 2 is 8. So the coordinate over here is 4, 8, for example. So this x-axis, this is y-axis. And now if you plot the inverse function of this guy, so that's y equals to x over 2, that's also a straight line with a gradient of half. So that's going to be, I think it's going to be like that with less gradient. Okay, so when x is equal to 8, then y is equal to 4. So a point, for example, over here could be 8 and 4. So that's 8 and 4. So one thing that we notice here is that these two curves, a function and its inverse function, they're kind of symmetrical with respect to this main diagonal. This diagonal is, of course, as you might expect, that's y equals to x. All right, we're going to investigate y equals to x squared and its inverse function y is equal to square root x as well. So here are the x's. That's x. That's y. Y equals x squared looks like it's a parabola. So it's a parabola like this with its other arm like that. And when I draw the square root of x, y equals square root of x, that one it's the positive. If I just take the positive root of x, that's just looking like this. Okay, so this case also, we see that this positive branch over here, not the negative bit, is symmetrical with this green bit, which is the graph of square root x, with respect to this diagonal line. Okay, and this diagonal here is also y equals x. If I draw y equals to negative root of x, okay? That's gonna be this. That's gonna be the mirror image of this green bit against the x-axis, which is like that. And as you can see that this black bit, which is the y equals x squared, is completely symmetrical with this green bit over here with respect to this main diagonal line of y equals x. All right, let's go for the exponential function. So y equals to 2 to the x. What does that look like? I'll do it here. So y equals 2 to the x is an exponential function. It always goes through 1 because 2 to the power of 0 is 1. And it grows really rapidly, much more rapidly than the square function. Okay, so one thing that you should understand is that the exponential function is really powerful, is much more powerful than any polynomial. Okay, and it decays down to 0. Okay, because as x tends to negative infinity, 2 to the power of negative infinity is like 1 over 2 to the power of like infinity. So that's going to be very small number. Well, I'm going to explain that to you, okay? So 2 to the power of, let's say, negative 100, okay? That's going to be 1 over 2 to the power of 100. That's going to be like, I don't know, you can sort of, that's sort of equivalent to 1 over infinity, I guess, because 2 to the power of 100 is a very large number. And 1 divided by infinity is pretty much 0, okay? So that's why it dies down to as x tends to negative infinity, and of course y equals 0, this middle this x-axis is an asymptote. All right, okay, so what does the inverse function of y equals 2 to the x looks like? So equation for the inverse function is log of base 2x. The graph of this one is simply just the mirror image of this blue curve with respect to this main diagonal, okay, which is y equals x again. So if we just draw the mirror image of this one, has to go through, because this one goes through 0, 1, this will have to go through 1, 0. It's just the opposite, okay? So it has to die down to 0, so it gets very close to the y-axis, and the logarithmic function is going to look like this. Okay, so that's the graph of log 2x. Okay, now what we're going to do is now draw the y equals to sine of x. I'm going to do that here. So that's the axis. And also draw the y equals to inverse sine of x. Okay, so we're going to zoom in a bit here. Not sure. Oh, can't zoom in. All right, so sine of x is going to be, as you know already, I drew it again actually. So that's 2 pi right here, and that's pi, and that's pi on 2. Okay, and toward the negative x-axis, it's just a continuation of the same looking curve. So that is the graph of sine function. Okay, now how do we draw the inverse sine function? All you have to do is just reflect this curve against the diagonal line. Okay, so which is the y equals x right here. So if we draw this guy, it will look like this. Just watch this. So I'm going to reflect this one against the y equals x, and it'll be like this, with this, and it'll be going down to -1, Okay, so that's what it looks like. Okay, therefore, for this curve right here, that value over here is nothing more than just pi on 2. Oh no, a pi, it's pi. And this value over here is negative pi, because that point corresponds to this point right here, that's pi. Okay, so however, you can see that this is not a function. When we just reflected this curve onto the with respect to the y is equal to x diagonal line, we get this green curve. But this is not a function, because when we actually use a vertical line and do vertical line test, it goes through 2 points. Actually, it goes through 4 points at the moment. So you're not supposed to have that for a function. Okay, so we actually have to restrict our domain in order to make it into a function. Remember, this is a function, and that's the inverse function of this function. So that must be a function, okay? So what we do is we only take, you see how that point pi on 2 is right here, so that's 1. So therefore, that point there is pi on 2, and this point over here is negative pi on 2, and it goes in the x direction 1, in the y direction that's negative 1. So we only take from here to here, all right? And you can just pretty much get rid of the green part, okay? So this is the look of the inverse sine function. You can just get rid of all the green part. Okay, so that's not part of the inverse function, because that violates the condition of a function. Okay, so that's the graph. So I'm going to redraw it again. So take a look. I'm going to rub it all off. And the function. So you must understand that the gradient over here is actually the same gradient as is actually 1. So you see, this is the line of y is equal x, and it doesn't actually go through this line and then comes out again. It actually is in alignment with the y equals x. Okay, and it comes down like this, and that is the look of the inverse sine function, and it goes all the way up to 1, negative 1. Remember, if you do inverse function, the y-axis becomes x-axis and x-axis becomes the y-axis. You know how the sine function used to oscillate from 1 and negative 1. So we're only taking this part right here. So from here to here. Okay, so that part, this point here corresponds to that point there, and it goes up, okay, and reaches over there, and that point over here, that point there is over here. Okay, and you know how this point is pi on 2, and this point right here is negative pi on 2. So it goes all the way up to pi on 2 and goes down to negative pi on 2. Okay. In like manner, cosine function, I'm going to draw a cosine function. So this is cosine of x, and it starts from 1 and goes down to negative 1 and comes back to 1 again. So that's 1, that's negative 1, and that value is 2 pi, right? So therefore, and it also continues to the negative x direction as well. So it goes down and then up. So that's the graph of the cosine function. And what we do is we also flip this against the y equals the x-axis. So that's the diagonal. And what we get is this. Actually, that's a bad axis. We get this. Starts from 1, so that's this point corresponds to that point. This is x here, that's y here. It goes down to 0, and that's going down to 0. Okay, and then goes to -1. Okay, and goes up like this, and that point corresponds to that point right there. So that's pi. Of course, it continues. Okay, but we don't draw this part. Okay, when we have to draw inverse cosine function, you don't have to draw this dotted part. You have to draw only this solid line here. Okay, yeah. So that's it for the inverse cosine function. So this one is y equals to inverse cos of x. The domain is from -1 to 1. As you can see, from here to here is pi. So where that point is, the y value for that is pi, and this value over here is pi on 2. So in summary, the inverse sine function is simply this. Like this, and like this. And that's pi on 2, that's negative pi on 2, that's 1, that's -1. For cosine function, for inverse cosine function, it is just it's just above the x-axis, like that, and that's it. So this is -1, that's 1, that's pi, and that's 2 pi. Oh no, this is pi on 2, sorry, and that's pi. Okay, so what is the domain for this? What's the domain? It's from -1 to 1. What's the range? It's just negative pi on 2 to pi on 2. What's the domain for this guy? The domain is also from -1 to 1, but range is slightly different. Range is 0 to pi. Okay, now let's do a tangent function. Tangent function. The original tangent function, as you know, looks like this. Starts from 0 to infinity, and that's where the asymptote is. And it also shoots down to -infinity, and that's where asymptote is. This is pi on 2. This is negative pi on 2. It just continues the same pattern. Okay, and this is actually that's actually pi on 2. That's pi, and this is 3 pi on 2. And yeah, the pattern just continues. Okay, but when we flip this against the y equals x, all right, this is what we get. So if you flip this one against the x equals to y equals x axis, this is what you get. I'm gonna do it in red pen. So the asymptote also gets flipped. So that's an asymptote over here, and there's another asymptote. And the function for, if I just draw this part, that part becomes this. Yep. And this part over here, the second part, is going to be just up here. Okay, it just repeats like that. Of course, we have to make it into a function, so you're not supposed to take another branch. So instead of taking this part and this part, we just take this part and this part as the as what makes up the inverse tan function. So we just have to ignore this part here. And that's the look of the inverse tan function. Value over here would be pi on, what was this value right here? So this branch corresponds to that branch right there. That's pi on 2. This is negative pi on 2. So this is y equals to inverse tan of x. And again, this is not the same thing as the cot function. The cot function was more like this way. This was the cot function. Remember from the previous video? Yeah, that's the cot function, and that's totally different from this inverse function of tan. All right.